right, we're still getting that challenge ready. I want to go ahead and give everybody an update of just kind of where we're at. Again, this is the final round. We've got MMM and we've got HypeBoy. We had just the closest match. They were both running locally, but not the payloads weren't working remotely. We're not sure why exactly yet. We're going to have to go back and look at it. We did have one, our test solver script, we were running at the same time. We were running that locally, running it remotely on the same server at the same time as them just to verify it was still solvable. That was still working, so we're pretty confident that the challenge wasn't broken, but we're hitting our time limit, and unfortunately, because we have a hard stop that we have to attend to and we want to have consistent rules, we had to pull that challenge back at the 50-minute mark. Every challenge in LiveCTF this year only runs for 50 minutes, and so we've got our sudden death challenge in, which is even easier. We sure hope. This one should be really, really fast. All the sudden death ones are very, very quick. It's just even more nerve-wracking. I feel awful for the players. I know how stressful that can be. We're preparing that right now. We're getting it in the system, and hopefully we'll be prepared for that soon. Do we have hints in that one too? All right, they're getting the config as rel. They're letting the competitors know. So we'll be back shortly. Oh, what a nail biter! So I'm going to pull up the chat again, see if we've missed anything. So the question in chat that I saw was, because this is a double elimination tournament, if MMM wins, will there be another round? And unfortunately, no. This is the last round. The rules that we published and gave to all the teams several days ago, we basically said the competition is double elimination until the very, very end. So if you actually look at the LiveCTF.com bracket that's been posted, there is no other match. This is the last match. Win or lose, this is it. It would be a bummer if HypeBoy doesn't get a second chance, but that's just, we didn't have enough time on the schedule. We didn't have enough ability to kind of run that in.
Yeah. Also, I mean, this is a way that you sometimes run double elimination matches.
Okay. It sounds like we're ready. So let's go ahead and queue up the competitors. Let them know that they should be on the page, and we'll do the countdown.
Okay.
Looks like they're both there right now. So let's go ahead and get this in.
Yep. 5, 4, 3, 2, 1, go.
And here we go.
And then we have the sudden death challenge started. And this is going to decide.
And I know nothing about this challenge. Do you know?
I know a little bit
right,
of this challenge. So this challenge is called Hopscotch. And so they made some changes to it throughout the development, but the basic idea is that you write shell code, but you control, I think it's like you control 4 bytes, and then there are 4 bytes that you don't control, and so on, repeating. So
okay, so basically 2 bytes of shellcode payload plus a 2-byte jump over the next 4, and you could arrange
if I remember. So as I said, like I might have, not the latest version of the challenge in my mind, but I think it's something like this. You do just like you said, a 2-byte useful, 2-byte relative jump, and you continue like that.
I've had a very real-world thing similar to that actually many years ago, where I had to write a similar payload. I got real good at knowing all the 1 and 2-byte opcodes in the manual. So HypeBoy went to the debugger very, very quickly as the first thing that they did. MMM, I saw they pulled it up in IDA earlier, and they're back now.
They already copying in the remote address, by the way, this time. So I've seen in a lot of the matches we have seen the players like not do that until they're actually throwing it against the remote. But now, they got it immediately there just to have it, so that there's nothing, once they have the solution.
Yeah, it is appropriate that, again, this is another shell coding. This is our sudden death shell coding challenge, which makes it appropriate for this particular one.
Right.
Here it is. And yes, the challenges will be all in GitHub like last year. So we will publish all of the solutions, all the challenges, all of our solutions anyways. The teams are welcome to publish theirs as well.
Yeah. So I think I see here, and I remember the shell script, their exploit script was that they were just throwing shell code immediately. And that's, I mean, this is sudden death. It's an easy challenge, but it's not that easy.
Okay, it's a little more than that. And
so maybe they just did that, without even, they just tried it, I don't know, just in case or something. But
without even seeing it.
It's very nice. But I want to switch over to HypeBoy, because here we have some actual debugging and stuff going on. And I think
they're looking at the string, the awesome string. You can see out what was written out, and so they're looking at what bytes were changed, how things have been modified. Yes. Now, are the bytes in between actually totally rewritten, or are they just randomized, or what happens? Do we know what happens to those bytes?
So I actually don't remember that part, but if I remember, I think it's a specific byte. It's a specific byte value that just gets placed there.
Written each time.
Yeah, but don't quote me on that or so.
And we're seeing HypeBoy have that same kind of workflow as before, right? They're still using that same online assembler disassembler. They use that to kind of go back and forth. It is interesting. Some people end up using like a little command line tool, like I had like dis.sh or asm.sh or a little REPL that they'll put something like Capstone into. And then actually over there on MMM, what's going on over there?
Right. So it looks like they're putting together a shellcode. And maybe they are going to attempt something like what you did. It looks like they're just getting the instructions there. Maybe they will, do the assembly to get the various bytes, and then try to maybe piece this together with some jumps or something else. Right, so we'll see how that goes. You see one function there just called remap page as read and executable, and then the so we have the exploit script there with what they're trying to do.
Over on HypeBoy, what I've seen is you can see the writing. There's again the hand-coded assembly, so they're doing a similar kind of approach. We've got these 2-byte opcodes of the moves, single XOR reg.
So if I understand correctly, they are doing the. You see, they add some knobs there.
Yes.
So they are kind of emulating the the modified bytes.
Is it only a single byte that's being written?
So
then,
this is where I might have been wrong. Like it might have been like you had a few bytes then, or something like this. So. Or
if it's only a single byte that's being written, then I really like that approach. There's no jumps needed.
You know what it could be?
It
could be that they are just adding those knobs as kind of like delimiters to know how to cut up their hex, like the byte string afterwards.
That's a good point too. They could be then reassembling it later.
So like you assemble, because if you just assemble your shellcode, you will just get a string of bytes, and you don't know like what bytes correspond to what instructions unless you're using some specific tooling for that. So like an easy, hacky way of doing that is to just put that knob instruction in between each instruction, then you can easily see these bytes are. It would be kind of like similar, like to just assembling one instruction at a time, but you're doing it in one go, maybe.
Here we go. So we've got, and you notice they've got that sleep in there. They're I think we're seeing the sleep over on HypeBoy's payload, because I think they're a little cautious about like the network socket, the remote. They may have already it may be in their head. They want to run up on something. Are we possibly this close? Or are we still just looking at how it's?
Yeah, it's hard to tell. Like when they're running these debugging, to try to see is it.
So they've got a full payload now. And they're going to write that payload into the buffer.
Right, so they do a staged approach to this one as well.
So their stager is working. They're going to go ahead and test it and see if it works. But they might still be, they're break. Okay, so they're still looking at the payload. They want to watch it run. They're going to check the registers.
Yeah. And then, well, I think there was almost working, but there was this, there's something, I think there's something that's off.
Him circling RSI.
Yeah, some, a little bit of, frustration or thinking about that. But it's... Yeah.
It seems like they have most of what they need.
Yeah, is it the rex instruction that it's being inserted in between? Well, I don't think I even know what that function, instruction does.
Well, the rex is right on 64-bit, right? Isn't that what puts it in? It's a prefix specifically if it's for.
Right. Yes.
64-bit or 32-bit. It was part of. Most of my shell coding days were all 32-bit. I'm just that ancient. So,
no.
But I believe the rex prefix is.
So how will that modify, or how will that change the behavior?
Well, the trick is you just don't want. You want to avoid it entirely, right? The answer is your payload should just work around.
Right.
It.
So, but in this case, like I was just thinking about like why. How did their shellcode behave differently due to those rex bytes? So
we're dividing a pointer. This is interesting. So what's? Yeah, I'm wondering how much, because again, there's a lot of ways you could do this. You could try to account for the bytes that are being written by working them into a working functional command. Like you could, like we've seen, like the pop immediate 8-bit, for example, would be one way you could eat a single byte afterwards, or pop.
And now we have the jump approach here going on. If we will see it here. You can see here, like you see a push, jump, and they're adding the labels, and they're just like doing the relative jumps to this. So this, I think, is definitely the way to go, right?
Well, sort of, except that push 0, we don't have a size on it, and so depending on if you've got a push 0 and it's like a 32-bit immediate, you're going to write 5 bytes. So A is actually right? That's
but I
think
be no. So let's see. Push.
I would have just done 4 nops under that A label if I wanted to skip over the A label. In fact, actually, I would have used another label. I would have put the label after it and jumped straight to the label, right? And then have my garbage there.
Oh, you're saying like you put like your jump instruction and you put like four knobs or something that like fake
Just
knobs.
put anything you want to get
yeah,
written
and
over.
then you do the label instead of doing the label plus an
plus
option.
the value. I feel like you're just setting yourself for it. Because again,
Yeah.
I'm not. Okay,
right.
they're jumping to A1. But yeah, I actually think that push 0 is a bad idea because I think it's going to default to 5 bytes. It's going to be a, was it 680000?
Right, because there is no immediate like there's no 16-bit push immediate instruction.
No, it's only 8 and 64.
Right, so you would have to do something like
or 32,
like XOR racks push racks instead to get that. Or something like this. So
let's see. I'm looking. Okay, but see, they're jumping over the A1, but they got a pop RC. I feel again. I still don't see like if the bytes that are being written. If there's multiple bytes, I would expect to see like multiple bytes of just not padding or something, right?
Yeah.
Just put a dB.
Right, but I mean this is kind of going in the right direction. But I guess it takes a little while to like wrap your head around this way of thinking with the shellcoding. Do that in an efficient way.
Let's check back in with HypeBoy. It's been a little bit, and so we've got a whole bunch of A's. Always a good sign. You want to run a bunch of A's over a buffer overflow. So a push 44.
So
and they're verifying that value. What do we got here? Okay, so now we do see 2 byte NOPs here. So we've got two NOPs, or actually more than that in a row. We've got 3. Okay, so they're doing an interesting pattern. So it may be that the bytes that are being overwritten are not necessarily contiguous too. So if they've, I think actually one thing would have been to do is just write in a bunch of nulls. It probably would have been easier to write a whole bunch of nulls, and if you could send those and then just see what bytes ended up at. Might have been an easier hint. It certainly would have helped us poor presenters as we try to identify what they're doing as we're watching them solve it. But I'm more confident, at least right now, in the way HypeBoy's payload is looking. Just looking at it as it has those NOPs kind of built in.
There's a syscall and a read there.
NOP-rex, push.
Yeah, but I really thought I saw a...
Okay, so they're checking the register value.
Yeah.
And RCX is not good, so they're going to need another... Yeah, so they're working on...
So shift left. Okay, no, interesting.
You probably need RCX if it's the whole width measure. That'll encode more efficiently instead of like the CL. If RCX
no, but it's shifting because they had a small number and then a larger number. I think I think they didn't care about the specific value, right? Maybe they just wanted a larger number, or they're trying to seems like they're trying to piece this together from these small instructions. Oh, is it possible that they are like doing basically making the rex a prefix of the NOP instruction?
Yes, yeah, they've done that several times. You can actually see them stepping through it. It goes
right,
rex, NOP,
right.
Rex, NOP.
So you effectively then get 3 bytes of useful. You do like in each 4-byte block, you do NOP and then your 3 bytes of whatever useful stuff, which is actually more efficient than the 2 byte plus the relative jump that we were talking about, and which MMM is doing. So this is actually So now I'm starting to understand what the NOP idea actually is. Okay, this makes now complete sense to me, and I think this is. I think it's both easier to write and more efficient.
Absolutely, because you're going to get for every sort of like chunk of unobfuscated stuff, you're going to get 3.
And you don't need to fiddle with like the labels and stuff in your when you're writing your assembly. As long as you like put your NOPs,
well, and you do have to be a little careful because some of those prefixes like can do weird things, and so like but again, they're stepping through it in the debugger. As long as the debugger doesn't change the behavior. Okay, that's off the end.
So
where are we at now?
Yeah, okay, so now it looks like they're just doing them basically one instruction at a time, inserting it, so you give the 3-byte instruction there.
We've seen this pretty consistently. HypeBoy really doesn't do a lot of
So I would say that this approach is marching steadily towards the answer.
Yes.
And it will work. The question is, will MMM
faster
catch up?
Yeah, let's go ahead and take a look back at MMM and see what they're up to as well. So again, if they've got like a full solution, although... Yeah, so we're still seeing the NOPs, right? We're seeing like single instructions and then jumps and then,
but you can see there at the top, you don't have the push anymore. You have a XOR AXAX. so you don't have the push with the immediate, which you pointed out, would be an issue.
Well, and I'm still.
Was that a
solution?
Wait, that is.
Wait, what?
That is
there. Is that it?
Well, let me get a.
That's it.
No.
We have a winner. Congratulations, MMM.
Oh my God!
Clearly it works.
Yeah, it works.
Clearly it works.
It
you
works.
Can't argue with success.
Yeah, that's
wow.
really cool.
That was.
Oh my God!
Stress.
What
Congratulations first to both of our finalists.
Yeah, that was.
They're both unbelievable. They're both
really
fantastic.
well played.
Best of luck. I'm sorry, HypeBoy, we don't have another round for you to be able to try one more time. But that was fantastic. We have to get all the scores over to Nautilus. We got to get the scoreboard. All the teams are going to go to the final award ceremony.
Yeah.
And we want to also kind of like bring out the LiveCTF team here too.
Right.
We've had a lot of folks that you haven't seen on camera.
Right. So basically, just to kind of like give like a very short recap over these 3 days, we have run this knockout tournament that's been running as a sub-event of the DEF CON CTF. We've had all the 12 teams of the DEF CON CTF finals participating in this double elimination one-on-one bracket where they each send one person to play. First one to solve goes on. The other person, loses. And yeah, we will, we're gonna wrap it up here very soon, and we will have recordings of all the matches that we have casted. We will be publishing all the challenges on our GitHub, together with some information about which team played in which match and links to the VODs and everything. So if you missed anything, you can go back and watch. You can try the challenges yourself. I think we will try to get the solve times as well, so you can try to try to benchmark yourself against these players.
We do know, for example, that we had also some network issues on one of the days, so we're gonna make sure we upload like the full quality videos. So we'll do separate matches. And you can, we want to see some races. Maybe in the future we'll let you race live. We'll let you challenges as the competitors see it too, and you and the audience. Let's get the rest of our LiveCTF crew up here.
Yeah.
Thanks to all of everybody that was a part of this. That's what Zoom is for. We'll zoom out.
So we've had a bunch of us. Okay, we have. A lot of us people here who have been contributing to this. We've had multiple commentators, including
guest commentators as well.
So Josh and Mark
thanks
here.
To V, thanks to Gomozo for coming out. And then this one's on the team. Yep, that's all right. You want to join us? Do you want to come on camera?
We are.
Do you want to come on camera? All right.
Checking with.
So we'll get the last little. We'll get everybody out here.
Yeah, just trying to get everyone here to like kind of
so that
close out this thing.
That last race challenge was actually a last-minute surprise from Kat, who joined us. So awesome. All right, we got everybody. That's it. I guess that's it for everyone. We'll say goodbye.
Say goodbye.
Bye. Bye.